clear and basic analytical techniques like FTL, EGM. Here you can see that on the first line, it is a cytosine, and by grafting monomer, that several peaks were through monomer constituent were appeared in the final hydrogen material. And after for the TG evolution, you can see that blue line, which represents the CPS, and after grafting insufficient monomer onto the thermal stability were considerably increased. On going to the point of zero charge analysis, the point of zero charge analysis is nothing but the your material shows that which charge is more dominant on the surface of the material. So around 7 pH, you will find make zero charge. And if we talk about the XRD analysis, so the here you can see that the radial represent through in XRD analysis is showing the pristine hydrogen sample, and the MMT claim was incorporated. So corresponding peak can be observed in the blue XRD data. On further going, the material were monitored through the several SEM analysis and optical microscopy also. So here you can see that the A represents the pristine hydrogen, and after incorporating MMTK, which is the monomer K, it substantially changed its morphological features. And ongoing with the same analysis, same observation was observed. So further, we verified the material's performance through several particle density and porosity of the soil. So in this, what was happened that we put our material into the real soil sample, and we after before and after was scenario was considered, and before and after how much porosity the material can help to generate the porosity, it was measured. And in soil water retention base, here you can see here you can see if the soil without the material, the soil cannot retain water, and the natural capacity of the soil is almost 10%. Sorry, up to the 10 days. But after putting our material and testing our material, it can be increased up to the 20, almost double of the time period. Since the material is utilized in the agricultural field, it is very important to consider its degradability also. That material itself cannot harm to the soil. So the material is also degradable, and it was evaluated that up to the 3.5 months or around 110 days, it can degrade itself into the up to the 50%, which is very good. And fertilizer and enterprise efficiency, if you show here that we use urea as a modern fertilizer. So it can bind up to suppose if we putting 1 gram, it almost entraps the urea or fertilizers in the around 95, and this is a composite material which is the same which we incorporated the NMT clay, and the capacity is further increased up to the 99%. So this is the urea release profile, and the two medium were considered. The first one is the water medium, and the second one is the real sample, and the real near to the real application we can say. So in the soil sample, it can here you can see the black line represents the conventional method of utilizing urea, that you put some fertilizer and it will be washed out around 4 to 5 days. But by using our material, it can sustain up to 10 to 25 days. And this simply means our material can release the urea up to the 25 days. So these are the conclusions that we performed, and these are the references which I have used during the research lab. So thank you. This is value imperial capitalism either the side regulation. First, business then PK, like the cost of capitalism. Yes, sir, I only am aware. Yes. What are the other calculations? Sir, we since NPK requires the 7 days to evidence that negative for a but we were just we were trying to just prove that the material is capable of release. So we just use urea as a model, not all the constituents of the NPK. Whether it was like the NPK materials, we will ignore it. Sure, sir. Yes, sir. So LSRM represent is the multifunctional system in these fertilizers. And due to the time limit, I have not show all the work which I have published. So the material itself is a multifunctional due to the several capabilities that material release fertilizers. It can absorb heavy metals, contaminants into their gel network, and it is also the water retention capability. So the one material can fulfill several action criteria in the farming or agricultural sector. That is why we term it as a multifunctional sustainable fertilizer. And recently we have also published this one. Sustainable. Yes. Sustainable stands for that you by using conventional method you get better prolonged release of time. Yeah. Yes, that is what it is. And the material itself is degradable, so it cannot harm the real thing, farm thing. In that one. Maybe.
Next is Yogi Sushi. Yogi Sushi.
Good morning. Myself, Dr. Yogesh Sushi, narrating the paper on AI-driven exploration of anisomilus nucleata for the wound healing and protective efficacy of against melanoma in experimental animal model. The aim and objective, basically the aim is to evaluate the anisomilus nucleata plant. The plant is very well grown into the Sahyadri ranges of the Western Ghats of Maharashtra. Objective to collect the plant first, authentication, pharmacoprognostic study, then the phytochemical study, then in vitro study. Before the in vitro study, in silico study is carried out. And lastly, in vivo study for the anti-cancer is performed in the present one. So this one is the pharmacoprognostic study, which basically used for the standardization of the plant material. So to set the monograph of the plant material into the Indian pharmacopoeia, we can use these in future also. Extraction and the phytochemical study mainly focus on to the main phytoconstituent diterpenoid overtadenoids is detected in the LCMS study also, and in preliminary phytochemical study also. In silico molecular document is carried out for the diterpenoid molecule. So the plan of work is very simple: in silico to the in vitro to the in vivo, and further in vivo to the clinical trials. So AI helps here for the molecular doctrine. For the molecular doctrine of the wound healing, it shows the good binding affinity for the two ADS protein. For anti-cancer activity, it also gives the good binding affinity for the protein. So this approach are used for the wound healing and the anti-cancer. To support the wound healing and the anti-cancer study, basically the antioxidant activity is also performed by using the three models which listed on the slides. Acute-thermal toxicity is also performed for the plant material. The plant material is very safe. We found in the higher dose more than 2000 milligrams per kg. Observations are carried out or noted down for the active toxicity study. Wound healing activity is performed using the thick gel at the 0.1%, 0.5%, and the 1% gel. So these are the images for the wound healing. We use the best effects into the 0.5 gel. The study is carried out basically for the 21 days. The wound size is drastically reduced on the day of the 8th to 10th. Constriction of the wound is also noted out. It's also drastically constricted on the 7 to 10 days. If you can see of the ethanolic extract of Anisomilus nucleata, the same is used for the study. The mice with namely C57DL Six, the cell line is introduced or injected into the B16F10 melanoma tumor cells on the dorsal portion of the animal. So it shows the tumor, the animal is said. After animal is get said, the various doses are given to the animal for the 21 days. So in the group second, it's a normal or the disease disease mice tumor is get isolated and diameter or the volume is calculated for the same. Group third is the allopathic medicine we have used. The name is in the previous slide as a dicarpacin. Group fourth is the black attitude, which also natural control we use, which is already proven for the as a plant material for the melanoma cell line. And then here in the last fifth group, we show the volume over here as our plant material. In summary, we can say that it has a good antioxidant activity, no doubt. So with the help of the molecular docking models, we can say the in silico study, we can utilize for the in vitro study, as that in vitro study we can use for the our in vivo study. The Anisomylus variana, lastly, we claim that it has a good antioxidant, anti-odorant activity, and the anti-cancer activity in the melanoma cancer cell. So it gives a strong evidence that we can this plant material into the future for the clinical trials also. So we also apply for the clinical trials right now with the help of the all these whatever the scientific data available with us. Thank you very much. If you have any question, please ask me.
I have a kind of a curiosity actually. So you have used the word AI and the orthodox software for the molecular doctrine we know from like several years. So how it makes AI sort of like get the or predict the field?
Yes, sir. Yes, very true. Sir, one of the guys in our pharmacy field, the pharmacology is the one of the subject is there. So instead of going for the receptor binding site on the animal, we use that software. It have the good we find out we use the software for finding out the receptor specific. So software AI use us, the molecular docking use us. The plant may have the good receptor activity on the so and so plant. Sorry, so and so activity or the so and so plant material have the binding property. So instead of asking for the 7 to 8 models, or instead of giving the pain to the animal, we use the AI tools for finding out the affinity or the which receptor it have the affinity.
Yeah, that I understand. But which software you have like what?
Yes. Or, yes. Yes, sir. Auto I use.
We use Autodoc, but Autodoc has been known from like several years for the molecular models for doctoral studies. So how like you have like integrate AI with the Autodoc or just you have used the Autodoc?
I just use the auto
Autodoc.
Yeah, I to get the idea of this, primary idea to get the primary idea.
Did you publish this work?
Sir, it's in the I didn't publish this one because the clinical trials are still pending. And this work is basically we are doing with the Tata Memorial Hospital. So with the permission of that time, Tata Memorial, we could not publish it. They gave me the permission to present over here.
That is very good work.
Thank you very much.
Next presenter, Rakshit Patel.
Hello, good morning, respected jury panel, expert, and my dear fellows. I, Rakshit Patel from Dharamsi Desai University, and under the title of my presentation is Esterification of Gallic Acid by using solid acid catalyst. I am research scholar in Dharamsi Desai University in the theme of green chemistry. So these are the outline of my presentation. My presentation is mainly divided into the three parts. In the first part, I am discussing about the introduction. Second is experimental. In the experimental part, I discuss about the material, catalyst preparation, and the synthesis of alkyl gallate, and characterization of catalyst. And lastly, result and discussion, conclusion, acknowledgement and references. So first, I'm talking about the introduction part. Solid acid catalyst is the most promising alternative of homogeneous catalyst, and the efficient approach in various chemical reactions. Now, our study is regarding the esterification of gallic acid by using solid acid catalyst. In the solid acid catalyst, we utilize H-beta zeolite, and the eco-friendly approach, the conventional corrosive and hazardous catalyst is replaced, and the catalyst activity is a particular facial separation, increase the selectivity, and the our product octyl gallate is utilized in the food industry, cosmetic, and pharmaceutical. So I'm talking about the catalyst preparation. So firstly, we prepare the H-beta zeolite. So from the soot chemical, we are taking the sodium form of beta zeolite, and the taking sodium form of beta zeolite is treating with the 1 molar 100 ml ammonium chloride solution. In the taking the ammonium chloride solution, 90 degree 4 hours. After the completed 4 hours, with ensuring the removal of chloride ion, and the confirming the chloride, we are replaced ammonium ions. Beta zeolite was subsequently dried in 100 degree, and the ammonium exchange beta zeolite is overnight put in oven, and then we are taking the ammonium exchange beta zeolite which calcinated 550 degrees Celsius 4 hours, obtaining at beta zeolite. The conformating at beta zeolite by the XRD, XRF, ammonia TPD, DET surface area, and FTIR also. So this is the experimental work of synthesis octyl gallate. We taking gallic acid and the octanol and the catalyst H beta zeolite. So in synthesis part, we taking the gallic acid and octanol, inputting the reaction tube, and reaction tube is putting the reaction station, and the RPM set 500 RPM, and the giving the temperature 120 degree. After the reaching 120 degree, we are adding the our catalyst at beta zeolite. After the completion of 4 hours, 120 degrees Celsius, completed 4 hours, we adding the ethyl acetate for the extraction of our product, and the filter, so normal filter. In the O part, we are getting the catalyst, and the after the 2 days natural drying, we are getting the our product octyl gallate. So catalyst characterization, we are performing XRD, XRF, DET, ammonia TPD, and FTIR. I'm talking about the FTIR. So we are performing the pyridine IR specially for the acidic site measurement on device or prostate. So we have found that particular H beta zeolite is giving this special good specific acidic site for the Levi's acidic site. It is mentioned in the particular 4415 in the particular, and the pyridine IR test, we are taking the 0.2 gram sample in this contact with the pyridine for 24 hours. And first of all, we putting the sample in pyridine IR chamber. We are activate at a different temperature 100, 200, 300, and 400, and carry the pyridine IR after 24 hours. So in the XRD pattern, we are getting 7.8 degree 22.4 2 theta value 101,302 confirming the H beta zeolite. Another is sharp band, it's 3651 centimeter inverse and 3213 for FTIR. So it is confirming the H beta zeolite. The particular the peak 1630 OH bonding absorb the water molecule, confirming SiO SiO SI in 1215 centimeter inverse 2630. We are here seeing the XRD H beta zeolite 302 and 101 for crystalline nature, and the particular the different peak for the FTIR is confirming the structure of H beta zeolite. Now talking about the DEP surface area is 549 and pore size is 58 and the ammonia activity 1.87 and the particular device acidic site is generated which is seen in the 1445 at different 100, 200, 300 and 400. Now the confirmation of octyl gallate by the IR. We are getting the peak 3280 OS 1667 for COO, 1220 CO, 3061 CH, and the other is confirming the structure of octyl gallate. Now the application of my presentation product, it is antioxidant, food additive, cosmetic applications are soap, shampoo, and pharmaceutical. It is also anti-cancer agent and some cancer agent also. So conclusion part, H beta zeolite is giving the most great potential in this area. We believe this work is very helpful in future. I am thankful to Food Chemical for the sodium form of beta zeolite. I am thankful to all particular CCAT for the testing and ammonia TPD Purna Institute. I am thankful to Center of Excellence for the giving the fund and my guide Dr. Atindra Sukla from Dharamji Desai University and International Conference giving him birth my presentation. These are the references we utilize for the work. And thank you very much to giving me chance. And now the turn for the question. If you have query, then please ask. I am happy there.
Yeah, I have one suggestion for you. Whenever you like you are doing some organic chemistry, at least show the yields of the product.
Okay, sir. If I am talking about the yield of product, so I start the gallic acid 1 gram and taking the octanol 1.43. So I calculate the yield. So I'm taking the yield is 82%.
How did you calculate?
Okay, we getting the gallic acid 188.14 and the particular octanol 130.23. So gallic acid is taking 1 gram, so 1 gram. So we Rafi particular 1 gram to so 130.23 divided by 188.14. So we calculating the theoretical yield. And after that gets practical yield. So percentage yield is theoretical yield divided by practical yield into 100. So we getting the total percentage yield.
Whenever you are doing some work, it shall be some rationale behind doing this work. So what are the other methods for the esterification of the carboxylic acid and alcohol?
Okay, sir, esterification method carboxylic acid or sub reported hai. So I taking the obtaining gallic acid because gallic acid is a natural antioxidant which is obtained from the green tea plants, grapes. So I am going for that because
that is fine. But what are the other methods available for the uptake of the carboxylic acid? Apart from your zeolite, did you survey like or did you compare with the other methods which are previously reported? For example, if you put the 1 drop of H2SO4 and reflect for 1 or 2 hours, you will get around 80%.
yes, propyl gallate is reported by this method, propyl gallate, but we are replacing the corrosive acid by this type of solid acid catalyst and trying the natural way to synthesize our product. Yes, sir. We trying 2 to 3 times we are getting the 1.0.1 catalyst again often. Thank you.
Next participant, Gita Chaudhary.
PhD scholar under the supervision of Professor Ashkishore Sharma from University of Delhi. Today I am here to present my research work that B-site engineered lanthanum-based double peroxide oxide for anion interpolation mechanism. This is the basic overview of my presentation. Firstly, we will discuss about the various type of electrochemical energy storage and conversion devices. Then we all know about the basic energy terms like energy stored in terms of mechanical, chemical energy, electrical energy, and electrochemical energy. We are basically working on electrochemical energy storage devices. The basic electrochemical energy storage devices like battery, supercapacitor, capacitors. The key difference all three are the energy storage and conversion mechanism. The battery have high storing power but very low conversion rate. But capacitor have high heat conversion rate but very low storing power. But the supercapacitor is split between the battery and capacitors which have moderate storing power and very high conversion rate. Why supercapacitor? Supercapacitor have various applications in portable electronic devices like wind energy and different type of electrode materials like carbon materials, activated carbon, carbon nanotubes, graphene, carbon dots, and some transition metal oxides which cause redox reactions and the breach of compositions of both. The supercapacitor is for supercapacitor have different type of charge storage mechanism like EDLC, that is electric double layer capacitors and pseudocapacitors. In case of electric double layer capacitors, the charge is not on the surface of electrode materials. But in case of pseudocapacitor, the Faraday redox reactions takes place at the surface of the electrode material and in the bulk of the electrolytes. And on the basis of charge storage mechanism, we further go for the practical applications, prefabricate symmetric and asymmetric devices. I choose perovskite as electrode material for supercapacitor. Why perovskite? Perovskite has its specific structure like the AbO3 type structure, whereas A-type catalysts are lanthanide and alkaline earth metal, but B-type catalysts are transition metals. And perovskite has some unique properties like its structural tunability and cations and anions. Anion tunability, anion interpolation mechanism in supercapacitor. Coming to the experimental work, B-site engineered lanthanum-based double peroxide oxides. Double peroxide oxide have some specific properties like synergistic effect of B-site metals, which is redox active. More ordered structures in comparison to single peroxide and single peroxides. Less lattice distortion and rapid anion interpolation kinetics mechanism. This is the schematic outlines of my work. Firstly, we took respective metal salt and extract salt few times. After that, we add a few drops of ethylene glycol and further followed by stirring and the gel is formation. After the destination 3 to 4 hours, we get respective desired double peroxide oxides which is present in monoclinic and tetragonal phases. This is the characterization techniques which I have used for the confirmations of structures and its applications purpose. Firstly, for the confirmations of double peroxide oxide, I have to XRD. From XRD, I confirm that lanthanum of cobalt manganese oxide is formed. And after its requirement, I observe that the lanthanum of cobalt manganese oxide is present in monoclinic phase. And further for the DFT calculations, I find out that the Fermi level of lanthanum of cobalt manganese oxide is present at 0 electron volt. And the optical band gap from total DOS, I observed 0.94 electron volt. And further for HR calculations, further for HR I observed the maximum intensity heat gains which is 112. And from SAT patterns, we confirms the monoclinic phase of the peroxide oxide. Further, I have done the P-site engineering. The cobalt is replaced by molybdenum. And the monoclinic phase of lanthanum cobalt manganese oxide is changes to tetragonal, which is more ordered in comparison to monoclinic phase. Further, TFT calculations, we observed that the optical band gap is decreased in comparison to lanthanum cobalt manganese oxide. And from HRM, more than one type of plant is observed. One is 213 plant and another one is 103 plant. And from SAT patterns, we also confirm that the polycrystalline natures and the tetragonal phase of lanthanum manganese molybdenum oxide is present. And further, we replace both P-site atoms, manganese and cobalt from molybdenum. And we observe that the monoclinic phase of lanthanum cobalt manganese oxide is changes to tetragonal, and which is highly ordered, and the expansions along the C-axis is observed. And optical band gap is observed 0.4 electron volt, which is lowest in all three structures. And the different type of plant is from HRM is observed, and which shows some slight atomic distortions and atomic defect, which is further responsible for oxygen vacancy in double peroxide oxide. And SAT pattern further confirms that tetragonal phase of lanthanum molybdenum oxide. This is the comparative table of all three structures. Here we can see the in case of C-axis, the expansion is observed, and the crystalline size from their expression we observe the crystalline size is decreased from lanthanum cobalt manganese oxide to lanthanum molybdenum oxide. Further for the confirmations of structures, we perform Raman spectra and FTIR. From Raman we observe in all three structures A, G band and PG band is present, and from FTIR spectra we confirm the metal or oxygen bonding in all three structures. Further for the structure analysis, we perform PET. From PET we observe that the highest specific surface area is observed in lanthanum molybdenum oxide, and the highest porosity and pore radius is observed. And from UV-DRS band gap analysis, we observe the 0.4 electron volt band gap, which is lowest in case of lanthanum molybdenum oxide, and which confirms the theoretical results. And from valence band here we observe the maximum valence band. From morphological analysis, we observe in all three structures that block-like morphology is observed, but the only key difference is the particle size. The particle size is decreased from lanthanum cobalt manganese oxide to lanthanum molybdenum oxide, and the particle size morphology is further confirmed by TEM analysis. And the index metric confirms the structure, percentage, and structure formations of structure. Further for the elemental compositions and charge storage setting, the P perform charge discharge XPS spectra. From charge discharge XPS spectra, we observe that the maximum oxygen vacancy is present in case of lanthanum molybdenum oxide. For the electrochemical performance analysis, we